Okay, so today we're talking about rates of change. Our goal for today is I can find the rate of change given a scenario. So go ahead and pre-rate yourself on this. Do you know what rate of change is? If you're like, yep, I can do it. I can do all this already by myself. Give yourself a 3. If you're like, I don't know what a rate of change is, give yourself a 1. If you're like, I think I remember this. I took Algebra 1 last year. I'm pretty sure I could do most of it. Give yourself a 2. Okay. So let's start with our first problem here. It says the table and graph model the draining of the pools at the Carroll Stream Park District and Glen Ellen Park District at the end of the summer season. So if you look on the left, there's a table. It says that's the data for the Carroll Stream pool. The column on the left is after how many hours have passed. And then the column on the right is the water that is left in the pool in gallons. And that's our X and our Y. If you look to the right, that's for the Glen Ellen pool. So it is in a graph format instead of a table format. So the first part says the Y-intercept is the point where the graph touches the Y-axis. Find the Y-intercept of each graph. So let's start with the Glen Ellen pool because I think it's easier to explain that way. So first off, you have to make sure you know that this is the X-axis and this is the Y-axis. So this point right here, notice it's always going to be 0, something. Right, the Y-intercept. This is 0, 1200. So my Y-intercept for the Glen Ellen pool is 0, 1200. And then if you look at this for the Carroll Stream pool, notice I already have 0, right here. So this is 0, 1600. So first thing you have to make sure you realize is that a Y-intercept is always a point. Okay, so it's a point, it's not a number, so it's not 1600 and 1200. It's the ordered pair 0, 1600 and the ordered pair 0, 1200. All right, the next question says, what is the meaning of these points in the context of the story? So remember, X is the time that has passed in hours, and then Y is the water in gallons. So this is both at time 0. So this is before you even started draining, okay? So you can say after no draining, it's how much water is left in the pool, or you can say it's the initial amount of water in the pool. Either one is fine. So I'm going to put the initial amount of water. Amount of water in each pool. Now, if they asked me, what does 3, 1300 represent, I would use the after 3 hours, there is 1300 gallons of water left in the Carroll Stream pool. Okay, so a Y-intercept is a point on the Y-axis. So we have to make sure we know that it's a point on the Y-axis. The point will always have 0 for the X value, so it'll always be 0, something. All right, how fast is each pool draining? Try to represent the rate of change. So we'll actually be writing our rate of change right now. So what we're going to do to look at that, to find that rate, is we have to look at how many gallons it's losing every minute, or how many gallons it's losing after a certain amount of minutes. Okay, so if I look right here, I can say, so I should say hours, not minutes. After 3 hours, how many gallons have I lost? So this is after 3 hours, how many gallons have I lost? That's negative 300, right? You have lost 300, so that's why it's negative. So I'm going to say my rate of change. Rate of change is represented by M because rate of change is your slope. So I'm going to say M equals, and then I'm losing 300 gallons every 3 minutes. Okay, now I do want to simplify that, right? Because I can simplify negative 300 over 3. That's negative 100 gallons every 1 minute. Or we can write that as negative 100 gallons per minute. You can write per like that. So that is the rate of change right there, negative 100 gallons per minute. All right, let's do the Glen Ellen pool here. So let's make sure we look at a point that we know, right? So I can say like This is over 1 up, and I'm like, I don't know how much that is. I'm not going to do that one. Over 2 up, I can see what that is. So that's 900, right? So if you look at what happened here, it went down 300, right? And that was after 2 hours. So I'm going to say M is equal to, it went down 300 gallons after 2 hours. I put minutes on the last one. It's not minutes, it's hours. Fix it. Hours. 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 No, gallons per hour. It sounds hours. It sounds weird. Okay, simplify that fraction. That's negative 150 gallons every 1 hour. Or how I'm going to write that is negative 150 gallons per hour. And that's its rate of change. Okay, so I've already said this, but I'm going to say it again. Rate of change is the same thing as the slope, okay? We use the variable m to represent slope. We already know that. And we could also realize from previous knowledge that slope is rise over run, which is the same thing as the change in y over the change in x, which would be the same thing as using y2 minus y1 over x2 minus x1 if you have a point x1, comma y1, x2, comma y1. Okay? So I want you to realize that what you could have done to get that point, or to get that slope, is you could have used the point 0, 1200, and you could have used the point 2, comma 900, and then use the slope formula, which is m equals y2, which is 900, minus y1, which is 1200, over x2, which is 2, minus x1, which is 0. That would have given me my negative 300 over 2, which would in turn would give me my negative 150 gallons per hour. Okay? Could have done the same thing here. Use this as a point and this as a point. So I'm going to be going through doing that in multiple different ways. Okay. Next it says write an equation for each pool to show the relationship between the number of hours draining X and the water remaining. So I'll start with Carroll Stream. I'm going to abbreviate it CS. Carroll Stream. I'm going to use Y, so I'll do Y equals. You can use F of X equals whatever you want to use. C of X. All right, so I'm going to do my initial amount, which is 1,600, minus, and then it's draining at 100 gallons per minute, so 100 X, right? So you could have also had Y equals negative 100 X plus 1,600. All right, for Glen Ellen, I'll do GE. For Glen Ellen, Y equals. And once again, I can do negative 150X and then plus what it started off at, which was 1,200. Or I can do 1,200 minus 150X. Either one is fine. Okay? All right. Next it says for each graph, calculate the slope and the y-intercept of the line. So what we're going to end up doing in the next set of notes is we're going to write equations of lines. And in order to do that, you need the slope and the y-intercept. Okay? So let's do each one of these. I like to start with y-intercept. So here's my y-intercept. I'm going to write that down. That's the point 0, negative 1. So now I need to find the slope. In order to find the slope, I need to find another point that I know is on the line. So I don't want to pick this point because I don't know where it is. I don't want to pick this point because I don't know where it is. I'm going to pick this point right here. And I like to pick a point to the right. It's just my personal preference. All right, now one of the ways that I told you to get slope is by doing the rise over the run, okay? If you go up or to the right, those are positive. If you go to the left or down, that's considered negative, okay? All right, so what I'm going to do is I'm going to ask myself, how do I get from this first point to this second point right here? How much do I have to rise? So if you look, you rise 1, 2. And how much do you run? 1, 2, 3. It's to the right, so it's positive. It's up, so it's positive. So your rise is 2 over your run is 3. Most of the time, your slope is going to be a fraction. The only reason it wouldn't be a fraction is if it was 3 over 1, which simplifies to 3. Okay, let's try this next one right here. So I'm going to do my y-intercept first. So here's my y-intercept. I can see that's over 0 up 3. Make sure you're not putting 3. It's the 0.03. All right, now I need another point on the line. I'm going to use this one right here. All right, so if I look how to get from the first point to the second point, I go up 1 over 1. So that is 1 over 1, which I'm not writing on my answer line because I know how to divide by 1. 1 divided by 1 is 1, so that's my slope. Okay, so please don't put ever as an answer something over 1 or something over -1 because we know how to divide everything by 1. We know how to divide everything by -1. Okay, we know how to divide by 3, but 2 is not divisible by 3. That's why we didn't simplify that. All right, next one. Go ahead and pause the video and try these two on your own. All right, that y-intercept is 0, 2. Slope, okay, I'm going to use that point. Once again, I like using points to the right. Okay, so I need to go from this point to this point. Okay, so I'm going to say how much I rise. So notice this time I'm going down 1, so that's a -1. And then I'm going to the right, so that's +2. So down 1, right 2. So my slope is -1/2. Okay, you can write it like that, -1/2, or you can put the negative in the numerator. Please don't put negatives in denominators. It just looks weird. And when you type it into a computer, it kind of rejects it as an answer. Not kind of, it will reject it as an answer. All right, here's my next one. Here's my point. So that's 0, -4. And now I need to pick another point that's on the line. I'll use this point. But let's say there was no point that's to the right. I'll show you, just in case that happens, how you can do it. Okay. All right, so I'm going to get from this point to this point, 1 to 2. And it doesn't matter which one's 1 to 2. You just have to make sure you make a plan of which one you're going from to. Okay. All right, so I'm going to start here, point number 1, and I have to say rise. This time I'm rising down 2. So it sounds like I don't know what I'm talking about when I say rising down 2, but down 2. Then I'm going to go right 1, so that's +1. So I have -2 over 1. Remember, never leave divided by 1 because we know how to divide by 1. So the slope is -2. All right, so let's go back to this one, and let's say that I didn't notice that point over there, and the first point that I noticed was this one right here. Okay, so I'm going to say this is my first point, this is my second point, going down to right 1. What if I said this is my first point and this is my second point? That's fine. How do I get from my first point to the second point? I have to rise first. I go up 2, and then I go left 1, which is -1. Still, 2 over -1 is still -2. So I want you to realize that you get the right answer no matter what. Last thing that I'm going to check before I move on, this is a positive number, so I need to have a positive slope line. If you look, it is positive slope. It's up to the right. This is up and to the right, so that's positive. 1 is a positive number. This is down and to the left, so negative. That's a negative slope. Down and to the left, so negative, and -2 is a negative slope. Okay, next we're going to look at a word problem, and it's going to ask us to find the rate of change. Then we're going to look at another problem that gives us a table, which is technically also a word problem. And one of the first things it asks us to do is to find the rate of change. So number 5 says, on the TV show Cupcake Wars, a team creates a wedding cupcake tower. The number of cupcakes increases by a constant amount for each new row. So it's going to be like +2, +2, +2, or +5, +5. And it says increase, that's why I'm saying plus. But it's constant, it doesn't change. Okay? There are 15 cupcakes, in the 4th row, there are 15 cupcakes. And in the 12th row, there are 39 cupcakes. What's the rate of change between the rows? So I'm going to write this down that in the 4th row, I know that I have 15 cupcakes. So in other words, I could also look at it as the point. I have the point 4, 15. In the 12th row, I have 39 cupcakes. So I want to know how many are being added each row, okay, because it's the same amount each time. So what I'm going to do is I'm going to use the slope formula. up here. Y2 minus Y1 over X2 minus X1. Since I have two ordered pairs. It's the easiest way to do it. So this is X, this is Y, and this is my first point, so 1, 1. This is X, this is Y, this is my second point, so 2, 2. And once again, the slope formula, the only thing people have ever messed up in my entire time I've ever taught is where the X's go and where the Y's go, okay? It's the change in Y's over the change in X's. Rise, if you think about rising on a graph, it's going up and down, which is Y's, right? Over run, so you shouldn't accidentally be putting X's in the numerator and Y's in the denominator. All right, so I'm going to say M equals rise over run, Y2 minus Y1. Y2 is 39, and then I automatically put down the minus. Y1 is 15 over X2, which is 12. Throw it on the minus right away. And then X1 is 4. And I say throw it down right away just in case it's a double negative, so you know to make it positive. All right, 39 minus 15 is 24 over 12 minus 4 is 8. And then I say, is that fraction simplifiable? And it is simplifiable because 8 goes into 24 3 times. So 3 over 1, which is just 3. And if you simplify right to 3, that's fine. Now remember, I just don't want to say 3. What is this? Remember, this was row. This was row. And this was cupcake, right? So my Y's are cupcakes. My X's is rows. So it's 3 cupcakes per row. And that is my rate of change. All right, let's look at the next one. It says, before heading off to college, Susie was able to save money from her part-time job. Now that she's in college, she has more expenses and must use the money in her savings account. The table shows the relationship between the amount of money in Susie's bank account and the number of weeks since she started. So it doesn't have the amount after every week. It's just not recorded in there, but it's going to be happening weekly, right? So I know that after 4 weeks, she had 4,010. She has 3,112, so on and so forth, okay? So it says, find the rate of change. What does this represent in the context of the story, okay? So rate of change is slope. In order to find slope, one thing that I could have is 2 points. I have 2 points here. I'm going to say this is my first point that I'll use, and this is my second point that I'll use. And you could pick any 2 you want, okay? All right, so remember, I'm going to use my formula again, where this is my first point and this is my second point. And it doesn't matter which 2 points you pick, you'll get the same answer if there's a constant change, okay? All right, so I'm going to do M equals, and actually first thing I'm going to do is I'm going to write down in words what this is. My Y is savings, so this is money. And then my X is weeks. And remember, it's change in Y over change in X. That's why I put Y as a numerator, X in denominator. Okay, so I'm now going to do Y2 minus Y1 over X2 minus X1. If you need to label it, you can. This is XY. This is the first one. XY. This is the second one. So Y2, which is 3,100, minus Y1, which is 4,000, over X2, which is 10, minus X1, which is 4. All right, 3,100 minus 4,000 is negative 900, over 10 minus 4 is 6. This is simplifiable because 6 does go into negative 900. It goes in there negative 150 times. So now I know my slope is negative 150, okay? So I can say M is negative 150. But it also says, what does this represent in the context of the story? So I need a rate on this, right? Because M equals negative 150 isn't showing a rate. So let's say what our rate is. This was dollars per week. So I can put a little dollar sign right here and then put per week if I want like that. So we're going to write it in the context of the story. We can say Susie's bank account. And since it's negative, is losing $150 per week. Now notice I didn't put negative $150 because I used the word losing, which represents negative. Next it says find the Y-intercept. What does this represent in the context of the story? So there are multiple ways of doing this. I want you to realize this. So I'm going to show you both ways, but you can do whichever one you want. First off, I'm going to start off by saying it's 0, comma, and then I'm looking for this something that goes right there. I'm looking for this. Okay? So one way to do this is to continue the pattern, right? I know that this is X and this is Y, and I already know that after 4 weeks she has 4,000, and she was losing money. So at 3 weeks she would have 150 more than that. So she'd have 4,150. At 2 weeks, she'd have 150 more than that, so she had 4,300. At 1 week, she'd have 4,450, and that means when she started at 0 weeks, she'd have 4,600. So that's one way, right? I still have to say what it means in the context of the story, but here's another way for more algebraic way. You could say, I know that the equation of a line is y equals mx plus b. I'm looking for b. I'm looking for what's the initial amount. So I say, okay, do I know a y value? So you can pick any y value you want. I'll use this point right here. And I'll say my y value of 4,000. And then I need my m value, which is negative 150. Make sure I can see my negative 150 there. Move this over a little bit. And then I need my x value for that. So I'm going to use 4 because 4 goes with the 4,000. So now if I went to go solve this, I do 4,000 equals negative 150 times 4 is negative 600 plus b. And then you can add 600 to both sides and see that b is 4,600. Either one's fine. Okay. But when it's all said and done, this is my answer. This is my Y-intercept. And then it says, what does this represent in the context of the story? So this is when Susie left for college. When Susie left for college, she had $4,600 in her account. Okay, the last part of what we're doing today is we are going to draw a line that matches the description. So we are going to, instead of I'm giving you this information and then you're giving me this information, so we're working backwards, okay? All right, so we are drawing a line for A that says has a y-intercept of 0, 4. So I'm going to start off by drawing a point right there. And a slope of negative 1/3. So first what you have to realize is that negative 1/3 is the same thing as negative 1/3, which is the same thing as 1 over negative 3. All of these are negative 1/3. Okay, you have to realize that. So the reason that it's important to know that is that when I type it in math type, it's going to look like this. You have to know it's the same as these other two right here. So let's start this first one right here. Remember, this is rise, this is run. So you're going to rise negative 1. That means you're going to go down 1. And then you're going to run positive 3. So that's to the right 3. Down 1 to the right 3. Now you could also do what this says right here. Oops, it's fine. Which this is still rise over run. So this is up 1 because it is positive, and this is to the left 3 because it's negative. So if I went up 1 to the left 3, I'd be right here. From that point, if I went up 1 to the left 3, I'd be right here. All right, so those are just my points. Now I need to connect those with a straight line. And then as we recall from chapter 1, I need arrows on the end in order for it to be a line. Otherwise, it's a line segment. All right, let's try the next one here. It says passes through the point negative 3, negative 3. So I didn't give you the y-intercept, but I did give you another point, which is good enough. So left 3, down 3, that's negative 3, negative 3. Has a slope of 2. So now what you have to realize is 2 is the same thing as 2 over 1, which is the same thing as negative 2 over negative 1, right? Because a negative divided by a negative is a positive. So let's start with this right here. Rise over run. Rise 2, that's up 2. Run positive 1, so that's right 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. Now looking at this here, it says that I could have also done rise over run. Rise negative 2, so go down 2. Run negative 1, so go left 1. So if I go back to this point right here and I go down 2, left 1, notice I'm just continuing the pattern of that line. Straight line, arrows on the end, and there we go. Oops. All right, go ahead and try the last two on your own, and then we'll check to make sure you did it okay. Y-intercept is 0, negative 1. My slope is 3/4. 3/4 is the same thing as negative 3 over negative 4. So a positive number that's a fraction is the same thing as negative over a negative, just so we realize that. All right, up 3, right 4. I can't make any more points to the right, but I could also go down 3, left 4. Oops, that's not down 3, left 4. Up 3. Oh, the first one wasn't up 3. It's only up 2. So notice how I noticed that really quickly. It's because if I went to go connect this, it's not straight, right? So I know I made a mistake on one of the points. And then I looked and I figured out that I didn't go up 3, right 4 for this one. Okay, and then this one right here, 5, negative 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, and then my slope is negative 1. So I have to realize that I could always take a number and put it over 1, right, to make it still equivalent to its original. And I could also say that that's the same thing as 1 over negative 1. Those are all three of those things are the same thing. Okay, they all simplify to negative 1. So I'll start with this one right here. I'm going to go down 1 because it's rise negative 1. And then positive 1 is right 1. Down 1, right 1. Or I could have gone up 1, left 1. So up 1, left 1, up 1, left 1, up 1, left 1. The more points, the better. I do as many as I can possibly get on the graph because I want my line to be accurate. Arrows on the end, and that's how you graph the line. Okay, so you can go ahead and re-rate yourself, and I can find the rate of change given a scenario. So we're thinking about going back to this, like, can you find the rate of change given 2 points? Here's another one. Can you find the rate of change given 2 points? Can you graph a line and then determine the slope and the y-intercept and vice versa? Were you able to find the rate of change here and the rate of change here? Okay. All right, that's it for today, or that's it for these notes, and we'll